Today in Engineering Newswire, we're ingesting tiny robots using a wearable keyboard to type anywhere and getting ferried around in driverless pods. Imagine having tiny robots climbing around your stomach. Kinda sounds like something right out of a sci-fi movie. But what if the tiny robot was ingested to help you? This is exactly what researchers from MIT and elsewhere are aiming to do. The team has developed an ingestible origami robot that unfolds when swallowed to patch wounds and remove foreign objects in the human body, such as button batteries. Apparently, around 3,500 of these batteries are swallowed in the US every year, sticking to the walls of stomachs and potentially burning the tissue. The robot consists of a heat-sensitive material called biolefin positioned between two layers of a structural material, in this case, pig intestine. When heated, the inside layer contracts, causing the bot to fold according to a slit pattern on its outer layers. The compressible design fits perfectly inside an ice capsule, which melts away when it reaches the stomach, allowing the robot to unfold. To get the robot to the stomach, the researchers applied magnetic fields to control the movement of a permanent magnet embedded in one of the robot's folds. By changing the magnetic fields, they allow the robot to rotate precisely enough to remove a button battery stuck to the wall of a synthetic stomach. Next, the researchers hope to redesign the robot so that it can control itself without the need of an external magnetic field.
The age of the keyboard is over. Welcome the Tap Strap, a wearable keyboard that lets users tap on any surface to type and works with Bluetooth devices. According to the startup manufacturer Tap Systems, the device is strapped through the fingers and can be worn on the right hand, left hand, or both for two-hand typing. 3 taps of the thumb will switch on the device, while 3 taps of the ring finger will switch it off. Once the strap is in place and switched on, it can be connected to the device to be controlled. Sensors in the tap strap monitor the movement of the hands and fingers. Different combinations of taps type different characters. For example, the 5 vowels are typed by tapping one of the fingers or thumb once. However, tapping 2 or more digits together creates other characters such as consonants, numbers, and punctuation. Currently, there are small, medium, and large versions of the tap strap, which takes 3 hours to fully charge via a micro USB. It can be typed for 4 hours or left on standby for 72 hours before needing a recharge. For those of you dying to strap the device on your hands today, hold your horses. The Tap Strap is being made available to beta users now and is expected to ship commercially before the end of the year.
The first public trials of a driverless vehicle initiative in London will soon take place. They're part of the $11.5 million federally funded Greenwich Automated Transport Environment Project. The tests are led by the UK's Transport Research Lab and will be conducted at the UK Smart Mobility Living Lab in the borough of Greenwich. But instead of having researchers and engineers test out the vehicles, they're opening up rides to the general public to give feedback on the experience. That's right, if you're feeling brave enough, you could even take a ride in an autonomous vehicle. The feedback will be part of a wider study with the aim of gaining a deeper understanding of how people think the move towards autonomy will affect the local communities. The project will use vehicles similar to the Ultrapods that have been ferrying passengers around Heathrow Airport since 2011. However, instead of using tracks, the vehicles will autonomously navigate routes using lasers, sensors, cameras, and software. And just in case of an emergency, there will be an operator on board to take the wheel if need be. So rest assured your pod won't accidentally go flying into oncoming traffic.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm Kaylee Duffy, and this has been your Engineering Newswire.